Okay, guys. Oh, what is that? There we go. This is our last lesson for Unit 4. So now we are looking at modeling with trig functions. So we've spent a lot of time looking at the graphs of trig functions, transforming the graphs of trig functions, and then being able to obtain the equation when given the graph of trig functions. So we should be able to be given any trig function and be able to graph it, as well as given most graphs and be able to figure out what the equation is. And that's ultimately what we're going to do is we are creating equations or functions that model situations so that we can use those to make predictions or answer questions regarding those situations. And so that's our goal for today. I can model periodic situations using trigonometric functions and use these models to answer questions about the situations. So there was a worksheet that I uploaded that went with this lesson, and it looks like this here. And so we're going to go through example 1 and 2. And I think, yeah, we'll do 3 as part of this lesson. I might break it up into 2 videos, depending how long it takes us. And then after that, there is more practice. So there's 1, 2, 3. So there's 3 more questions. These are very tricky questions. So I do recommend that you for sure do the practice. I will post the solutions for these. You might even want to try these questions on your own and then come to the video to check your understanding. Or maybe we do the first one together. And then for the next one, you're like, okay, I'm going to try this one on my own, and then go check for the solution in the video. So I have taken the data from that first question. The first question, really, there's no context. It's just giving you data, asking you to plot it, and then asking you to determine the equation. So we're not using the equation, but this is, again, just practicing that skill of getting information from a graph and turning it into an equation. What is different is our x values, our independent variable, are going up in increments of like numbers, not necessarily radians. And so we always need to make sure we can convert back when we're dealing with our trig functions. Using that formula we talked about, the period is equal to 2 pi divided by k. So here's what the data ends up looking like when you take the values from that table of values and put them on the graph. And so we have this kind of what looks like a flipped sine curve. If you think about it, our sine curve usually starts here at the origin and then heads upwards towards its maximum, x-intercept, and then its minimum. And a flipped or a vertically reflected sine curve, a negative sine x, would head down first and then reach its y or x-intercept, its max, and then back to its another x-intercept. So this one's heading down first. So I'm going to break this down in like kind of steps as I'm noticing things. So I'm going to say, okay, because this is heading towards its minimum before it heads towards its maximum, let's start and say that it's been reflected. What's going on here? Okay, so this is being reflected. So right away, we're going to start and say, so far we're dealing with y equals negative sine x. Now I need to take a look at the amplitude and the period. So the amplitude is the distance from the midline. So here I've drawn my midline of my function here. And, sorry, just 1 second. Oh, never mind. Our staff 50-50. It's Friday afternoon here. So our amplitude is the distance from the midline to the max or the min, and we can see here that that distance, our midline is happening at a y value of 6, and our max is at 8. So we have a distance of 2, meaning the amplitude is 2. So if the amplitude is 2, we could say that our working equation is y equals negative 2 sine x rather than 1. And then the period of this function is, sorry guys, I'm going to pause this video. There's another long announcement. Okay, hopefully that's the last announcement. So the period of this periodic function, one full rotation, is here. So one full rotation is 10. Now we have no context. We don't know 10 what, but we know it's, we can't say that that's 10 radians, like when we're dealing with our untransformed functions, we say, 2 pi radians. But what we do have is this formula that we can use to determine the period for any periodic function. And that formula is, sorry, I wrote periodic, but I'm just trying to write while I talk. And that should just say period. So the period is equal to 2 pi divided by k. And ultimately, when we create the equation, what we want is that k value. K is the value that goes in front of our independent variable. And so in an untransformed function, 2 pi is the period. In this function, 10 is the period. So what we can say is that the period, 10, must be equal to 2 pi divided by k. Now we need to figure out the k value so that we can put it into this function so that it will work when we are graphing, when we're using our calculator. And so the long way is we multiply both sides by k to get our variable out of the denominator. And I can just kind of show you what that looks like. And then we would have 10k equals 2 pi, then we'd have to divide by 10 on both sides to get k by itself. Ultimately, kind of what we end up doing, and the reason I'm just showing you why that happens, is these essentially end up switching places. So we could also say that k is equal to 2 pi divided by 10, which is equal to pi over 5. 2 over 10 is 1 over 5. So the k value is pi over 5. So now our working equation is going to be y equals negative 2 sine pi over 5x. And if we applied all those transformations, this is what our graph, oh, no, sorry, I'm missing one. We've got this vertical transformation. So far, the reflection would cause the graph to head down. The amplitude is what's causing it to, even though it doesn't look like it, but it does have a vertical stretch because the amplitude is 2. We have the k value impacting the period, which is allowing for this curve to have a period of 10. But it's also been shifted up. The normal location of the midline in an untransformed sine function is on the x-axis or at y equals 0. And now the midline is at y equals 6. So this entire function has been vertically translated. Okay, so vertical translation up 6. So therefore, we can use a different color. Our final equation is going to be y equals negative 2 sine pi over 5x plus 6. Now, we don't have to put brackets around this because there is no brackets. We know that that plus 6 is not a phase shift. It's not a horizontal movement, but it also doesn't make it wrong if you do decide to put brackets, so it might look like that as well. Okay, so that's just taking some information from a graph, creating the equation. We're not going to actually use the equation to answer any questions in this example.